So, dear students, so let's start our class. Before we start, please confirm that you are able to hear my voice very clearly and able to view the screen.
Yes.
Okay. So, dear students, so yesterday I gave one question and I got a solution from most of you. So those who are yet to solve it, please do let me know. Uh, I gave the question like this. Or if you need any assistance to understand this question, that also you can let me know. But what is important is that you please solve it and do let me know those who are yet to solve it. So this is the question what I gave. Um, Now, what I would like to discuss today is that questions related to finding the range of a quadratic polynomial. You remember that when we discussed about the minimum and maximum values of the ranges of real quadratic expression, we consider two cases. One is that range when x belongs to R, and the second one is that when range is in a restricted domain. So in our earlier session, you found that we solved some problem related to when the range, when x belongs to R. Okay, that means for any values of x, how we can find the range of a quadratic polynomial. But today, what we are going to do, we are going to solve some problems where we are going to find the range of a quadratic polynomial when it is a restricted, domain. Okay, and for that, what was the underlying theory? If you recall, dear students, that the underlying theory was that I just want to keep it for your notice here, um, and you need to apply these concepts properly to find the values. Uh, the relevant discussion already I made it in my earlier session. You can look into those YouTube video lectures as well if you wish to find how to find the uh, the ranges on a restricted domain. So here the domain is restricted, as you see, dear students. The domain is actually D to E, that is the restricted domain. This is the underlying theory we discussed, right? So now, yeah, hi, dear Sagnik, thanks for joining. We are just started our class. Just started. We are going to solve some problem related to range in a restricted domain. Anyone has any question in this particular, theory portion? Please do let me know. Uh, in simple terms, what I can say is that if fx is the polynomial, as you see it here, and we need to find the values of x, we need to find the minimum and maximum value in the restricted domain D to E, closed interval. So then what we need to find is that we need to first find the value of fx at 3 points. First point is D, that is FD we need to find. Second point is FE, that is at the other extreme point of the interval, restricted domain interval. And the third point, that depends on a condition. We need to first find the value of minus b by 2a. And if this minus b by 2a is in the open interval region D to E, then we find the value of f minus b by 2a. Now we need to find what is the minimum and maximum among these three, this FE and FD. If we find the minimum value, that we define as lowercase m, and the maximum value we define as uppercase m. So this is the minimum and maximum value, and the restricted range, or the range you can say we get, is the closed interval lowercase m to uppercase m. So there it has to be a third bracket. Correct. So fine, dear students. So now we are going to solve problems related to this theory, because it is important. Questions comes from here. What I want you to do is that first, you please take a note of this question and also start solving along with me. Okay. So the first question is that find the range of fx equal to 2x square minus 3x plus 2 in the domain 0 to 2. That is a restricted domain. Okay, dear students, so if you found the value, do let me know. Otherwise, I can start solving it and you can also do along with me. So what are the, points we need to find the value? First, you need to find the value at f0, correct or not? All of you agree to me that we need to find the value of that function, expression fx at the function fx y equal to fx. You can say function, but here it is a polynomial expression fx. So f0 we need to find. So 2 into 0 square minus 3 into 0 plus 2. So we get the value of f0 is equal to 2. Correct, not your students? The next one, what you need to find? You need to find the value at f2. What is f2? f2 is the 2 into 2 square minus 3 into 2 plus 2. It is 8 minus 6 plus 2. That is equal to 4. So we get the value, first value we get is at 2, second value we get is at 4. Then we need to first find whether minus b by 2a, what is minus b by 2a according to the theory? Got it, no? Dear students, the minus b by 2a, third point, that minus b by 2a is belongs to 0 to 2 or not, open interval. So let's first find minus b by 2a. Now, if you resemble with this equation with ax square plus bx plus c, means if you assume that fx equal to ax square plus bx plus c, and if you make a comparison between this one and this one, what we are going to get, dear students? We are going to get a is equal to 2, b is equal to minus 3, and c is equal to 2. So then what is that value of minus b by 2a? So minus of minus 3 divided by 2 into 2, 2 into 2, that is 4, that is equal to 3 by 4. So what we see, that 3 by 4 belongs to the open interval 0 to 2, na? 3 by 4, as you can write, 3 by 4 belongs to the open interval 0 comma 2. So we need to find the value of fx at 3 by 4. If you find the value of fx at 3 by 4, what we are going to get? We are going to get 2 into 3 by 4 whole square minus 3 into 3 by 4 plus 2. And dear students, if you simplify, you will get the value as 7 by 8. Now, what is the minimum value? Minimum value m is nothing but the minimum among f0, then f2, and f of 3 by 4. Correct or not? So if this is the case, then what we are going to get? What is the minimum? That is equal to, you can write, what is the minimum between, minimum among 2, 4, and 7 by 8? That is equal to 7 by 8. And what is capital M? Capital M is nothing but maximum among f0, f2, and f3 by 4. Correct or not? So that is equal to, sorry, here I need to write minimum. So here I am writing it is maximum among 2, 4, and 7 by 8. So what is the maximum value? 4. So what is the restricted range then? So not restricted range, we can call it as a range. Okay. So the required range, is 7 by 8 closed interval to 4 closed interval. Now, dear students, without using these steps also you can solve it by completing the square. By completing the square also you can solve this question, but it will take relatively longer time. So better to memorize this thing and do it accordingly. Clear? Now, dear students, I am going to solve a different type of problem. Means the expression what I am going to give you a different type, and we will see that how it is going to work. Everyone understood very well? Disha, Srijita, Divyansu?
Yes.
Yes.
Kathy,
Yes, sir.
Mohor?
Yes.
Yes, sir.
Okay, great. Good. Now the next question what I'm going to give is something like this. Is that, find the range of the function y is equal to, I'm just going to give it here, y is equal to 3 minus 2 sine square theta minus 6 sine theta. So here it is the range of y is equal to 3 minus 2 sine square theta minus 6 sine theta. You may think, sir, you have not given any restricted domain. We are discussing about restricted domain, but you have not given any domain. And dear students, it is actually there inherently. Let me use a different color so that you can make a difference with respect to the previous solution of what I did. So you please also do along with me and learn the way, I am using the concept of trigonometric functions and how I converting to a pure algebraic function. Okay, learn this concept. And this learning is very, very important. And that these are the learnings you need to apply in you whenever you get this kind of questions later. So what we are assuming, let sine theta is equal to, write it as x. If we write sine theta is equal to x, this implies y is equal to 3 minus 2x square minus 6x. Correct, no? Clear or not clear? Now, dear students, very interesting. Could you please tell me what is the value of x it can take? What is the value of sine theta? What is the minimum value of sine theta?
-1.
Minus 1. Very well said. And maximum value of sine theta?
1.
Plus 1. So
1.
that means that value of sine theta can vary from -1 to +1. Hence, we can say that x can vary from -1 to +1. So that is your restricted domain. Correct or not? So you see the question what is given y is equal to 3 minus 2 sine square theta minus 6 sine theta. From there we actually converted to a polynomial function with a restricted domain. And this is the concept. That's what I said a minute back. it is inherently defined. The restricted domain is actually informed inherently. So now it is pretty simple. So let me write this thing, the function y, y is equal to fx, by the way. So we can write y is equal to fx, and we will write in proper manner, that is ax square, that is ax square plus bx, that is minus 6x plus 3. Now we are going to find the value of fx at 3 points. First point is at f of minus 1. Second point is at f of plus 1, that is 1. And third one is that, you know, at the point minus b by 2a. That is also depends on whether minus b by 2a is in between the open interval minus 1 to plus 1 or not. So what is the value of f of minus 1? We find it out 2 into minus 1 whole square minus 6 into minus 1 plus 3. That is equal to, we get minus 2 plus 6 plus 3, and we get this as 7. Correct, dear students? What is the value of f1? Minus 2 into 1 whole square minus 6 into 1 plus 3, that is equal to minus 2 minus 6 plus 3, and that we get is actually minus 5. And before finding the value of fx at x equal to minus b by 2a, first we find what is minus b by 2a. What is minus b? Minus b become minus of minus 6, minus of minus 6 divided by 2 into a. 2 into a is what? It is 2 into minus 2, correct or not? 2 into minus 2. So that is actually getting 6 by minus 4. 6 by minus 4 means is minus 6 by 4, which is doesn't belongs to, open interval minus 1 to plus 1, because minus 6 by 4, that is minus 3 by 2, is actually less than minus 1, correct or not? So what we are going to find, we don't need to find the value of f at minus b by 2, fx at x equal to minus b by 2. So only we need to find which is the minimum and maximum among them. So what is the minimum? Minimum is lowercase m, we can minimum is minus 5. And what is maximum? Maximum is capital M, that is equal to 7. So what is the range? So the required range is minus 5 to 7. So the required range is minus 5 to 7. Clear? Absolutely clear, dear students?
Yes, sir.
Hmm?
Yes, sir.
Okay, great. Now, you see how efficiently we are able to do it by learning these steps. But if we think that no, we do not want to learn these steps, you want to go with the traditional method, you can go, but it will take longer time. What is the traditional method? It is the completing the square, and it will take, certainly it will take longer time. Now, dear students, what I am to discuss is called the solution involving quadratic rational functions. Okay, solving inequations involving quadratic rational functions. And here you will see, dear students, this kind of topic, you can find that, sir, this has been discussed during our topic of inequalities. Yes, but this is a particular type of problem. Here, what we are going to discuss is a particular type of problem, where the inequations in that function, in the rational function, you will see the coefficients of any of these rational functions is unknown, and we need to find the ranges of that. Anyway, before speaking more on that, let us first understand what we are going to achieve. And to achieve this one, first we need to understand what is uh, a rational function. If you remember, dear students, is that if you find any function fx is equal to px by qx, where px and qx are polynomials is called rational function. If the degree of px is less than degree of qx, we called it as an proper rational function. Otherwise, if that means if the degree of px is greater than equal to degree of qx, we call fx as an improper rational function. What we are going to achieve here? Suppose a inequation is given something like this: a less than px by qx less than b, where a and b are known to you. It will be given. What is a and b? Px and qx, that is also you know, but you know what will happen in any of that coefficient in px and qx. Any of the coefficient in that expression of px or qx will be unknown. And we need to find the ranges of that unknown. We need to find the values that unknown can take, so that the inequation that a less than px less than q, a less than px by q less than b holds true. Let us take an example. Then you will understand that, okay, why is Harry saying so? For example, we want to find, the first condition, first question, what we see is something like this. If for any real x, we have -1 less than equal to x square plus nx minus 2 by x square minus 3x plus 4 less than equal to 2, then find the value of n. This is the question. You see what? As I was telling that if you resemble with the statement here, a is what? -1, b is what? 2. And one of the coefficient in px in this case is unknown, that is n. So what we need to find? We need to find the ranges of n or the values of n it can take, so that this inequation, that given inequation, is actually true for any real x. This is a slightly different type of problems, okay, than whatever we solved in inequalities chapter, correct or not? And why I didn't discuss this type of problem there, because to solve this kind of problem, we need to have knowledge of that inequation related to the quadratic polynomial. And that we have done already in the last couple of sessions. Hence, we are going to solve this one. You tell me one thing, dear students. General mistake, what we do is that general mistakes, because I should inform what are the general mistakes students generally do, is that we have a tendency that whenever we get something like this, that -1 less than equal to x square plus nx minus 2 divided by x square minus 3x plus 4 less than equal to 2, we have a tendency to multiply everything with x square minus 3x plus 4, so that we'll get, there is no numerator by denominator. But that is wrong. Why that is wrong, we are not sure now whether x square minus 3x plus 4 is greater than 0 or less than 0. Correct or not, dear students?
Yes.
Correct or not? Okay. In this case, it is greater than 0, because from the quadratic inequality, we will find that if you look into this particular case, if I use a different, x square minus 3x plus 4 to have greater than 0, what are the two conditions has to be satisfied, dear students? First, a has to be, if a is greater than 0, then d, that is discriminant, has to be less than 0. What is discriminant? B square, that is 9, minus 4ac minus 16, that is less than 0. So as a is greater than 0 and d less than 0, so obviously we can say that yes, x square minus 3x plus 4 is actually greater than 0. Correct or not? So in this case, it is fine. But you cannot do always. Got my point? Because you need to make sure whether x square minus 3x plus 4 is greater than 0 or less than 0. Here x square minus 3x plus 4 you are saying, but in other question it could be different. So first make sure whether it is greater than 0 or less than 0, then depending on that you do. But I am going to tell you a very generic statement, generic way of doing this thing. Generic way of doing this thing, dear students, is that first we need to consider the right part. Let me use a different color. From this inequation, we consider the right part. If we consider the right part, what we are going to get, dear students? We are going to get, let me do it here. So let me do it here by giving the space. So what we are going to get it here, x square plus nx minus 2 divided by x square minus 3x plus 4, correct na? Then we can take minus 2 less than equal to 0. So now we can simplify. This implies what, dear students? That is, numerator will get x square minus n plus 6 into x plus 10. I'm not doing that simplification because then it will be wastage of time in context to our present discussion. And x square minus 3x plus 4 is less than equal to 0. And we just observed that x square minus 3x plus 4 is greater than 0. So we can multiply, and what we'll get is that we can multiply both sides with x square minus 3x plus 4 equal to 0, and we can have the inequality remains intact. That is x square minus n plus 6 into x plus 10 is less than equal to 0. Correct or not? Okay. I made one small mistake. I think it should be greater than 0. X square minus x square plus nx minus 2 by x square minus 3x. So what I did is that it is minus 8. So I multiplied everything with minus. So this minus is actually less than equal to 0. So that means this particular thing, if we multiply both sides by minus, so that should be greater than equal to 0. I didn't do all the simplification because you understood, right? Because we should learn what is the main thing here. Now, let us look into this particular, quadratic inequality. Now, under what condition this quadratic inequality should be greater than 0, dear students? This should be greater than equal to 0 if a is greater than 0. A is greater than 0, na? What is a is? A is here is 1, na? The coefficient of x square, correct? That is greater than 0. That means the discriminant has to be less than equal to 0, na? Correct or not? If you recall, fx is greater than equal to 0 when a is greater than 0. That means discriminant has to be less than equal to 0. Correct or not? So what is discriminant? This implies what? What is the discriminant? Discriminant is that, b square minus 4ac. Correct? What is b square? B square is that n plus 6 whole square minus 4ac minus 40. Correct or not? B square minus 4ac has to be less than equal to 0. Now we can simplify it further. So n square plus 12x plus 36 minus 40 plus 36 minus 40 is minus 4 is less than equal to 0. Now we can factorize. How to do this thing, whenever you get this kind of situation, the first thing is that first we need to do that n square. Oh, I'm sorry, there is a mistake I have done. Instead of x I should write n. Here I should write n, not x. Sorry. So n square plus 12n minus 4 equal to 0. We'll do it. And then we'll find the two roots and then we'll make a factorization. So that implies what? What will be n then? Minus b, that is minus 12, plus minus b square, that is means 12 whole square means 144, b square minus 4ac. That means b square minus 4ac means minus 4 into minus 4, that is plus 16 divided by 2. So what we are going to get then? N is equal to minus 12 plus minus square root of 160. Correct or not? 160 divided by 2, and you can make that 2 divided, then what you will get, n is equal to minus 6 plus minus square root of 40. Correct, na, dear students? We can write minus 6 plus minus square root of 40. So then what are the values of n we are getting? Minus 6 plus square root of 40. So we get the values of n is equal to minus 6 plus square root of 40, and another one is that minus 6 minus square root of 40. So now that thing we can apply here back, and what the fraction we are going to get, let's see. So n minus 6 plus square root of 40, that we can write, na? And we can write n minus 6 minus square root of 40 is less than equal to 0. So from here what we can say, when you remember, dear students, x minus alpha into x minus beta less than equal to 0, that means what? X is in between alpha and beta, minimum of alpha and beta, less than x, less than maximum of alpha and beta, but here it is n. So what we can say? We can say that minus 40 minus square root of 6 is less than equal to n, less than equal to square root of 40 minus 6. Anyone has any doubt, please do let me know. This is the number one equation we get. In equation we get ranges of values. Dear students, absolutely clear?
Yes.
Now, okay, great. Thanks for confirmation. Now, what we are going to do is that we are going to take the other part of the inequation. So let me do it in a different color. So let me do it in a green color. So now what we are going to do, dear students, we are going to take this part of this inequation. Now, if we take this part of this inequation, what we are going to get, let's find it out. So from here, what we get is that, we can write is that minus 1 is less than equal to x square plus nx minus 2 divided by x square minus 3x plus 4. Correct? Now from here, what we can write is that, from here what we can write is, we can write x square plus nx plus 2 divided by x square minus 3x plus 4 plus 1 is greater than equal to 0. Correct or not? I hope all of you agree to me. So now, as x square minus 3x plus 4, we can take that as LCM. So x square minus 3x plus 4, we can take it as LCM. And what we get, dear students, in the numerator after simplification, we'll get 2x square plus n minus 3 into x plus 2 is greater than equal to 0. I'm not doing this simplification because it is quite straightforward. Now, we just learned few minutes back that x square minus 3x plus 4 is always greater than equal to 0. So we can multiply this quantity, that is x square minus 3x plus 4, both sides of the inequality without keeping the inequality sign changed. So what we are going to get, 2x square plus n minus 3 into x plus 2 is greater than equal to 0. Now, under what condition, dear students, this has to be greater than equal to 0? We see that a, which is 2, that is greater than 0. Correct? No, that we need to find what is a. A we are getting is 2. So a is equal to 2, which is greater than 0. Then definitely the discriminant has to be less than equal to 0. What is discriminant? B square, that is n minus 3 whole square, b square minus 4ac, minus 4 into a is 2 into 2. That should be definitely less than equal to 0. And dear students, beginning of the discussion of this particular topic, I said that I didn't solve this kind of problem in the inequality days. Why? Because here you need to apply the concept of quadratic polynomial, inequality. And that is why, as we have learned, you see how efficiently we are concluding this thing from this one, that 2x square plus n minus 3 into x plus 2 greater than equal to 0. How efficiently we are concluding that, yeah, oh, coefficient of x square 2, which is greater than 0. Oh, definitely the discriminant has to be less than equal to 0. Efficiently. But without having that knowledge, if we start solving in the beginning, it is difficult. Now, after that, what we are going to apply, that n minus 3 whole square minus 4 into 2 into 2 is less than equal to 0. There, that is actually a concept of inequality. That there we need to apply our knowledge of inequality. So what we are going to get, dear students, from here, let's simplify it. N square minus 6n, correct, na? Plus 9 minus 16 is less than equal to 0. This implies n square minus 6n minus 7 is less than equal to 0. So here we need to do a simple middle term factorization, the splitting the middle term. So what we will get, n minus 7 into n plus 1 is less than equal to 0. So that implies what? From our knowledge of linear inequalities, we can write, in more simplified manner, n minus minus 1 into n minus 7 is less than equal to 0. Remember, dear students, our discussion on linear inequalities. You can also look back to the linear inequalities relevant videos, that if x minus alpha into x minus beta is less than equal to 0, that means x is in between minimum of alpha and beta and maximum of alpha and beta. That means minimum of alpha and beta less than equal to x less than equal to maximum of alpha and beta. And that's the same thing we are applying here. Instead of alpha x, it is here actually n. So this implies what? Minus 1 less than equal to n less than equal to 7. So this we are giving at equation 2. Now, dear students, our solution set should satisfy both equation 1 and equation 2. Correct or not? Our solution set should satisfy both equation 1 and equation 2. Actually, in equation 1 and in equation 2. And for that, what you need to do? We need to, represent all these things in the number line, and we need to find which is the common solution set, common interval. Correct, no? So this is a number line, big number line I am drawing. And dear students, you all need to make, a relative positioning of these numbers. What are the numbers we should consider here? First number will be minus 40 minus root 6. Second number should be square root of 40 minus 6. Third number should be minus 1, and fourth number should be 7. So now, if we look into that, square root of 40, so first let's put minus 1 and 7. So suppose this is minus 1 and this is 7, for example. So minus 1 to 7, if we put, dear students, so it is, let me use a different color. Okay. So minus 1 to 7, it should be filled up because it is closed interval equal to, so minus 1 to 7. I hope all of you understood. Now, we need to find minus square root of 40 minus square root of 6. Definitely it is less than 1, na, dear students. So minus, if I use a different color, so let me use a color this. So this should be, first let me point the value here. Let me use a different color called, let me use this thing. So minus square root of minus 40 minus square root of 6. So that is a relative position. You don't need to be very, very accurate. I repeat, minus 40 minus square root of 6. Here the question is not that you need to, you need to place the point exactly. It is not like that. You need to just relative position. Okay. And then square root of 40 minus 6. Square root of 40 minus 6 is, so what it will be here, square root of 40, if we see, so we can find the approximate value. So what we are going to get, dear students, if we find um, approximate value of square root of 40 minus 6, if we find, so then we'll get it is a positive number, that is 0.32 kind of this thing. So it will be here somewhere. Correct, no? So then that should be square root of 40 minus 6. So now if I draw that one in a different color called this one, so the another solution set what we are getting, dear students. So minus square root of 46 minus square root of minus 40 minus square root of 6 to 40 square root of 40 minus root over of 40 minus 6. Let me slip up my term, dear students. So let me tell you what I got. Okay. So this what is seen in the yellow, it is actually represent that closed interval minus 40 minus square root of 6 to square root of 40 minus 6. Correct, sir, dear students? Achha, I made one small mistake here. I think it's one small mistake. So it is a typo. It is square root of 40. Right, no? If you see, it should be square root of 40 minus square root of minus 6. Correct, no? So then eventually I need to correct it here. And we get it here. This point is minus of square root of 40 minus 6. So what are the different points I get? So this represents that yellow line. What you see, dear students, is that this represents, so I can draw once more so that you should not have any confusion. So the yellow line I'm going to draw is that the representing the closed interval minus square root of 40 minus 6 to square root of 40 minus 6. Should be something like this, starting from here till going to this part. Correct, na? So now, so this one represent solution to the equation in equation 1. And if you look into the blue line, that represents the solution to in equation 2. Now, what you need to find? We need to find a common solution to be satisfied by both. And common solution should be what? From here to here. Correct, no? So that is, so what we get is that n belongs to the closed interval minus 1 2. N belongs to closed interval minus 1 2 square root of 40 minus 6. That is the value of n, so that the given inequation is going to be satisfied for all values of x. Correct, no, dear students? You got it? So this inequation, what you see, this inequation is going to be true. This inequation is going to be true if we take the value of n as minus 1 2 square root of 40 minus 6 closed interval. So this is a quite a new type of problem. Correct or not? Now, dear students, the next problem we are going to discuss, I'm just going to give you a little bit of hints and you need to solve it and do let me know. And here is the question. Question is that find the value of k. Find the value of k. You can also do along with me. The question is that find the value of k so that the inequality mod of x square plus kx plus 1 by x square plus x plus 1 less than 3 satisfied for all values of x. Okay. Apparently it looks like, sir, it is a little difficult question, how to proceed, but not really. If you remember, dear students, I'm just giving you the hints you need to do and you need to let me know later. I'm just going to give you some little bit of hints. And first and foremost thing is that we need to first break down that problem, you know, uh, with a smaller one. So first we need to understand, recall our, modulus inequality, dear students. If you remember, if we say that mod of x less than a, what we conclude, dear students? We conclude that minus a less than x less than a. Recall?
Yes.
If you recall this thing, then quite obvious that from here, what we can say? From here we can say, oh, one thing we are sure, minus 3 less than x square plus kx plus 1 divided by x square plus x plus 1 is less than 3. Now, dear students, let us focus on that expression x square plus x plus 1. For any real value of x, you know, x square plus x plus 1 always has to be greater than 0. And that we can conclude without having any knowledge of our quadratic inequality. You take any value of x, positive, negative, okay, always it will be positive. Na? But still we can apply. Still we can apply our knowledge. Let's look into that x square plus x plus 1. What is a here? A is equal to 1, na? Greater than 0. Now what is d here? The discriminant b square 1 minus 4ac, that is minus 3, less than 0. So for a quadratic polynomial like ax square plus bx plus c, remember, if a is greater than 0 and d is less than 0, that implies what? That implies ax square plus bx plus c is greater than 0. Correct or not? So if you apply this, all these are background knowledge. That's what we are writing in a different color. So that knowledge also you can apply to conclude that x square plus x plus 1 is greater than 0. Now as it is greater than 0, so we can multiply both sides of the inequality without changing the sign of the inequality, now, dear students. So what we get? Minus 3 into x square plus x plus 1 less than x square plus kx plus 1 less than 3 into x square plus x plus 1. Correct, not, dear students? So you can write in bracket, since x square plus x plus 1 is greater than 0. Correct or not? Now, dear students, what you need to do? You need to break into the two. That's what I want you to do. You need to break into the two parts the way I have done in the previous question. First, you need to break into this part. Correct or not? From here, you get a set of solutions of x. And you need to break into the other part. Correct or not? And by solving this thing, you will get another values of x. And you need to club together. And then, find what is the common solution between them. Or if you want, sir, you do, I also do along with you, we can do this thing together. Okay, you open your pen and paper and do along with me. I'm doing slowly, na, dear students. So what is happening for the left part? So left part means what, dear students? What we are going to get? Minus 3x square minus 3x minus 3 less than x square plus kx plus 1. So if we do this thing, what we can write is that 4x square plus k plus 3 into x plus 4 is greater than 0. Dear students, this quadratic polynomial is greater than 0 in which the coefficient of x square, that is 4, is greater than 0, then definitely the discriminant of this corresponding polynomial equation has to be less than 0. No? Correct? So what is that? B square, that implies k plus 3 whole square, b square minus 4 into a is 4 into c is 4, that must be less than 0. See, very simple way of showing the statement. But simple, subject to the condition, you remember what are the previous things we have discussed. If you do not remember the previous thing what is discussed, this is one of the most complex one. You're not able to enjoy, right? You're not able to find the, you're not able to connect it. As if that you started watching a movie from the middle of it. You're not able to enjoy, right? Correct. So then what happened is that, what you can write is that, so this implies k square plus 6k plus 9 minus 64 is less than 0. Hmm? So from here, what you can write is that k square plus 6k minus 53 is less than 0. Now let's look into it. Okay, now if we look into this one, that what we're going to get it, that if we look into this, that in this particular quadratic polynomial, that k square plus 6k minus 53, a is greater than 0 and b square minus 4ac is also greater than 0. Correct, no? A is greater than 0. A means what? Coefficient of s k square, right? Which is 1, that is greater than 0. And if you find the discriminant is what? B square. So here 1 is greater than 0, that is a from here. And b square, that is 6 square minus 4ac, minus 4 into a into minus 53. That is also greater than 0. So definitely this is less than 0 for all k. So you don't need to, so this is actually for all real number k. So you don't need to bother too much about this one, left one. So now let's come to the right side. Right side we are writing in blue. So this implies what? This implies, dear students, first we write the expression. All of you are able to get it, dear students? If you do not get it, never hesitate, because you are learning. But today if you do not ask, later it will be a problem. 3x square plus 3x plus 3. So then what we are going to get here, dear students? So it is 2x square plus 3 minus k into x plus 2. Okay. Plus 2 should be greater than 0. So now what we are getting, dear students, is that here we see that a is greater than 0. Correct, no? A is greater than 0, that is a is 2, and polynomial expression is greater than 0, then definitely the discriminant has to be less than 0, na? So from here, what is the discriminant of the corresponding polynomial equation? It is 3 minus k whole square minus 4 into a is 2 into c is 2 should be less than 0. Now let's simplify. 9 plus k square minus 6k minus 16 is less than 0. This implies k square minus 6k minus, it is 15, correct? Oh, I'm sorry, not 15. It is actually coming as a, it is minus 7, right? Minus 7 is less than 0. K square minus 6k minus 7 less than 0. Correct? So now what we can write from here is that we can write k minus 7. Did I write properly? It is 9, 16, k square minus 6k plus 9, b square minus 4ac. Yes, I did correct. K minus 7 into k plus 1 is less than 0. Correct or not?
Yes.
Now, from here, what we are going to get? From here, we are going to get is that minus 1 less than k less than 7. Correct, no? Minus 1 less than k less than 7. Clear or not clear? Did you get it?
Yes, sir.
Okay. So this is the solution set. What we get? Hmm. Any doubt, dear students? Just a minute. Let me look into the blue and the green part of the solution once more. So it is b square minus 4ac should be less than 0. No, here one point is that. So just a minute. Let me look into this particular solution, dear students. So let me erase it. I think there is a small mistake I have made it here. So we get what? K plus 3 whole square minus 4 into 4 into 4 less than 0. So from here what we can write, dear students? We can write k square. So k plus 3. So let me write it down here. It is k square plus 6k. K square plus 6k plus 9 minus 64 is less than 0. So this implies k square plus 6k plus minus
55.
minus 55. Yeah, that is the mistake I have done. Less than 0. So this implies what? K square plus 11k minus 5k, correct? Minus 55 is less than 0. This implies k into k plus 11, correct? Minus 5 into k plus 11 is less than 0, correct or not? So this implies k minus 5 into k plus 11 is less than 0. The previous computation I did wrong because of this computation of the constant term. So from here what we can do, dear students, that minus 11 is less than k, it's less than 5, correct or not? So this we give as equation 1, and this we give, the blue one we give as equation in equation 2, not equation, in equation in this case. So now we need to find a common solution. For that we need to draw a number line. So this is infinite towards, it is minus infinite, and midpoint is 0. What is the point? What is the point minus 1? So let's first point the equation in equation 1. So in equation 1, so for that we need to interested about the point called minus 11, and the other point is called 5. So minus 11 here, 5 here. I repeat, dear students, you need to be little bit of relative positioning has to be correct. And for the in equation 2, the first one is that minus 1. Suppose it is minus 1 is here, and 7 should be right of 5. That is 7 here. Now let us draw, in the green color, the inequality represented by the inequation 1 in the number line. So minus 11 to 5. So it will be open interval because it is less than. So unfilled circle, minus 11 to 5. Minus 11 to 5 should be something like this. And let me draw the green color, a blue color for minus 1 to 7. So minus 1 is here and 7 is here. So now what is the common solution, dear students? So common solution should be
This one.
minus 1 to 5, which is overlapped. So this is one part and this is one part. So minus 1 to 5, this is the overlapped one. So the required values of k belongs to the open interval minus 1 to 5. I am sorry, dear students, for making the mistakes in this part, which initially I wrote in the green color. Later I corrected it. You got it right. So this is the way to solve, this kind of inequality problem. Okay, and where the coefficients value we need to find it out. These are the different techniques, dear students. And after learning the techniques, you need to practice it, and you can always practice from the online test platform. There are very relevant problems are there at www.konarclasses.com, and you think that you'll find that your idea is getting very clarified. So how to do this thing? So for example, you want to appear, just a minute, I can tell you very quickly. Most of you are aware of it, but just for the sake of, just to illustrate that whatever I just said, that how efficiently you can do it. Suppose you learn this thing, you solve couple of problems from by your own, and after that what you need to do, you just need to go to this website www.konarclasses.com, and you see how efficiently you can appear for a test. Log in, give your login and password. Done. Go to the right practice test. Just here write theory. You see theory of equations came. Practice test. Within a second, within a minute, sorry, not within a second, within few seconds, we are land up with these great quality questions. Start solving these questions. The moment you submit it, you get your answers, then being discussed with us, and you see the how the knowledge is actually getting very rock solid over a period of time. So this online platform, why I always say, dear students, this has a very quality questions, extremely quality questions. But do not go to this practice test unless you solve the DPPs. DPPs, without solving DPPs, if we start solving practice test as if like that, we are preparing for Mount Everest and we are not into the first base camp. First, you need to practice with the first base camp, right, dear students? If you are not preparing for going how to go to the first base camp and directly go for the Mount Everest, you know that it may not be a very pleasant experience. Same thing here. So first you need to go to the right online examination. Then you search for that, quadratic. You see, started getting. I hope few of you already submitted, but few still need to. So these DPPs has to be solved first. After that, practice test. Okay, dear students. So with this, I would like to conclude the class for today, and we'll have our. So meanwhile, let us discuss that what is the suitable time we can have our class in every day. So please be in discussion over WhatsApp. Tomorrow anyway we have a holiday, so no class, but from Monday we need to fix the time. Everyone put your, you discuss with your parents, you look into your school timing, and then do let me know what is the most suitable timing you have. Then I will consider all of this and find a proper timing. Okay, dear students, with this I would like to conclude the class now. Thank you very much. See you on Monday.
Thank you.
Thank you.